Yes, yeah, exactly. So just like we want this to be diagonal, so we wish that was always diagonal. This is the best we can do under the circumstances. So the first column is determined by that. And then do you know how to get the second column once you know the first? Okay, then it's, I don't know how much of the D, it's a little bit of algebra, it's not too bad. I'm going to skip it. If you're interested, you can ask me in office hours for a book. Fairly decent job of explaining this. I'm going to show you how to get the S matrix. You're going to have to help me out again. So it was a -2, and what was the top there?
1 minus 3i.
1 minus 3i, is that right?
Yeah.
So again, I'm showing you the mechanics. This actually works. So you're going to break this the eigenvector down into a real part plus I times another real part, which is the real part and the imaginary part. And then, again, it's just kind of weird the way it works out. Is the first column of S is the imaginary part, and the second column of S is the real part. And if you work this out, you'll see the S times R times S inverse, you'll end up with the original matrix.
Wait, sorry, where did the -2 come from? That was just the other eigenvalue, or?
No, there were two eigenvalues. And so we had lambdas 4 plus 3i. This was an eigenvector.
Right.
And this was the second one. And actually, we can get all the
Okay.
information from
Okay.
the first one. So, let's do another one. So the key idea here is you want that middle matrix to have a nice shape, have a nice structure, and you want everything to be a real number. And the key idea is recognizing that multiplying by a complex number is just a rotation and a scaling, and you can do that with a matrix. -5, -1. We want to come up with the SR S inverse factorization. So when I say SD S inverse, the D is diagonal. When I say SR S inverse, the R is rotation scaling. There are a lot of steps here. Let's start doing it. Remember this minus lambda along the diagonal, do the AD minus BC.
It's 5 times 1 over 5 times 2.
Thank you. That's what I said. So this is +5. I'm much happier with this. So that was gonna go south in a hurry. We found the eigenvalue. We got the eigenvalues of lambda equals 1 plus or minus I. Okay, the nice thing, to get the SRS inverse, well, you know what, do both of these. We can do everything with just this one. But I showed you a shortcut that I want to remind you of, is once you get the A plus BI eigenvectors, it's easy to get the A minus BI. So I worked it out. When I do the matrix times xy, I'm going to get the same thing as 1 plus I times xy. There's going to be a way to do this without having to use x equals 0, y equals 0. And so when I multiply that out across the top, I get 3x minus 5y is 1 plus I, and x minus y is 1 plus iy. Minus 2y. So these are really the same equation, is if you multiply top equation by 2 plus I, it turns it second. You want to use the first equation or the second one?
Second.
The second one. Excellent choice. So I showed you a shortcut for this. What should x be?
2 plus I, 1.
1. And the signs already are opposite, so we're good with that. Would you be good with that? See if you plug those numbers in, you're going to get 0.
Good question.
Yeah.
Can you remind me, did you say the equations are always going to come out or they're the same?
Yes.
Okay, and that's coming from, what, is that a quick answer to say why that happens?
Yeah, because if they're not the same, then the only solution to this is going to be x equals 0, y equals 0. And we specifically did this part to see there was an answer that didn't happen.
Great.
So again, I don't need this, but you know the shortcut to go from this eigenvector to this one? What is it?
2 minus I, 1.
Good. So again, to solve this problem, we only need the first one. So to find the s, we're going to split this up. If I just take out the real parts,
Yeah, 2, 1, 1, 0.
so I split that up. Copy that over here. So we're doing the RS, R inverse factorization. R is a rotation scaling matrix that does exactly the rotation and scaling of the eigenvalue. So there was an easy way to get that. It's what's the first column of R?
1, 0.
No. Oh, no, the rotation scaling part comes from this, so it's 1. Everybody good with that? And a rotation scaling matrix looks like this. So what's the second column of R? So that's the rotation scaling matrix, and again, it's just rotating and scaling just like that complex number does. And then